My name's Luke Cove. I'm the Director of Lightning Energy. We've been doing this for about 6 or 7 years, but this showroom we've only had for a couple months, so this is a new thing. So thanks for coming and seeing what we have to say. So today we're going to talk about EV charging. So I've got some people in from the industry. So we've got Reece here from Ohme and we've got John here from My Energy. So we're going to talk about Ohme first, and then we're going to talk about My Energy after, and we're going to do a bit of a Q&A at the end. So if you have any questions, maybe just hold them till the end. And there's a bit to get through, but yeah, I think I'll hand it over to Reece. No worries.
Hello, thank you everyone. I'm quite surprised there's quite a few people here this morning, and thank you for taking your time out of a beautiful day to come down and listen to us. I'm the country manager and head of sales for Ohme Australia. We're a UK brand. I've been in the industry for about 10 years. So I started in New Zealand. I was working for a utility company there, and I sort of project managed AC and DC charging infrastructure throughout Auckland. So very back in the sort of early pioneering days. My first EV was a Nissan Leaf, or first generation Nissan Leaf. And since then, I've probably had about 9 or 10 different types of electric vehicles. And that's going from, full BEV to plug-in hybrids, electrics, and currently driving a Tesla Model 3. So like even in that sort of time, I've worked on a lot of different types of EV charging solutions. One of them being vehicle to grid. I know that there may be some interest in there, but we won't be talking about that today, but did projects on those, going back to 2016, 2017. In that time here in Australia, I've also worked for other sort of EV charging brands, Delta Electronics and AC and DC charging. And I was also the country manager for Wallbox chargers. So that one's another popular one that sort of introduced the first bi-directional charging in South Australia, the Quasar one. So Ohme, look, we are a UK-based company, but we have sort of branched out across Europe, and in Australia sort of being, down in the Antipodes on the sort of far outer edges. We've been here, a relatively short amount of time, 2022, but we've really only started kicking off sales at the start of this year. We've put together quite a knowledgeable team. Everybody in the team has sort of EV charging experience. And Bradley, this guy right here with no hair, he used to be the head of product at Ohme UK. So any sort of changes required for our local market, he sort of spearheads that for us. So as an example, all of our products that you may see at the back up here have been developed specifically for the Australian market. You'll also notice in the sort of product code that it has AU in it. So what else do we do? Here's more of the team. So look, we get out and about in Australia. We're based all up and down the sort of east coast, Melbourne, Sydney, and Brisbane. We also work in sort of the mobility space. So we're particularly strong with it in the UK, and we're sort of transitioning all that knowledge base and relationships and partnerships here in Australia. You'll also see down here something you may be familiar with, OVO Energy and Octopus, which isn't here in Australia, but the platforms that they use for their energy, we do have sort of integrations with there, and I will talk about that a bit later on. So let's talk EV charging. Does anybody know what this is? Not quite. So this is an onboard charger. And what does the onboard charger do? It converts the AC energy that we get from your home to DC, and that goes into the battery because the battery receives DC energy. So in your typical EV, that can range from 3.6 kilowatts in those old first generation Nissan Leafs 3 to 22 kilowatts in some of the older Teslas, and some of the newer vehicles that are coming out now have 22 kilowatts onboard chargers. Teslas, you'll see around 11 kilowatts. But you'll also see a lot of single phase around 6.6 or 7 kilowatts. So what does this do? It determines how fast we can actually charge our vehicle. So why is this important? So our homes, single or three phase. So most homes, are between 40 and 63 amps. When I was living in Toorak, the house that I had there was 40 amp supply. I had a swimming pool, I had 4 air conditioning units, I had a spa pool, plus I had an EV to charge. So you can, you start worrying about sort of capacity within the home. So there are some things when you look at EV charging, versus dumb versus smart. So making the right choice on that, your charging can sort of balance that load within it. But further to that, it's more about the vehicle and what it can do within that sort of supply. So say a single phase home, you can't charge more than 7.4 kilowatts in a single phase home. So look, I've got a Tesla. The onboard charge is 11 kilowatts. So I can't charge more than 7.4 kilowatts at my current residence. So in saying that, if they try to sell you, something more than what's capable, it's probably not a good fit. And again, this is what I've said here. And, and if your EV has a 6.6 kilowatt onboard charger, like this MG4, the maximum it can pull from a single phase is obviously 6.6, not 7.4 if your charger says so. Another consideration you need to take into account. This little MG4, 6.6 kilowatt onboard charger, and you've got a 3-phase home. You've installed an 11 kilowatt or 22 kilowatt EV charger. If you've ramped it down to 11 kilowatts, so that's 16 amps per phase, the max energy that you're going to pull is 3.2 kilowatts. And the reason being, it's a single phase onboard charger. It's only pulling energy from one of the phases. So that's one of the considerations when installing, an EV charger, that you choose the right one. So I'm not saying not to install a 22 kilowatt, but if you do, and you've got people visiting that may have a single phase onboard charger in their EV, that they may be pulling, sort of a lower amount of energy. What are some other things to sort of take into consideration? Sort of level 1 chargers. So these are sort of charging devices or EVSE that sort of get supplied with vehicles, or you can purchase them. So, what's good about them? The convenience. Every house has a power point, 10 amp supply that you can plug these into. It's portability. You can take it with you. And again, cost effective, relatively cheap than a level 2 charger. And it doesn't require an installation. You're using the existing sort of electrical infrastructure for it. And the other one is safety, because it does have inbuilt protection devices within the device. So what are the cons? Sort of power availability. So, you're only going to have a certain amount of power within that device and not necessarily what you would in a level 2 charger. The control box weight. So for example, if you've plugged this device into a wall, power point may be so high, that could be hanging off of that, and any sort of movement on that, could cause a safety issue. The same can be for the cords, because what people tend to do is plug these into extension cables. Big no-no. Don't do it. Because what also happens is people don't uncoil those extension cables, and as it's drawing that constant sort of temperature, it heats up, can cause a fire. Another one is sort of output adjustment. Some of them you can't actually adjust the sort of amperage, and one of the biggest one is smart features. Level 2 has a lot more smart features. My colleague here from our industry colleague here from My Energy will also sort of discuss some of these as well. So sort of level 2 charging. Pros, charging speed. You know, you're going to get 3 to 4 times faster than a level 1 charger. So that's also sort of charging time. You know, the speed that you'll actually get your vehicle charged is going to be considerably higher. They're safe and secure. So, you know, it's usually that you can sort of lock out the device. On Ohme chargers, you can actually prevent people from the app or from the actual screen itself, from them people accessing it. And smart features. I'll go into smart features a little bit more because there's quite a few in there. Cons, cost. Considerably more expensive for the unit itself, but also installation. So, you know, you've got to consider single-phase installation and 3-phase installation. Now, this is something that I sort of discuss from my learnings in New Zealand. So back then it was install the biggest and best, install 22 kilowatt chargers everywhere. So, and so they did that, but what happened, especially like in commercial context, is they were putting 22 kilowatt chargers, but as they increased the fleet, they've soon realized the capacity of energy within that building wasn't enough to support that growth. So what made more sense to them was scale it back and put in single phase chargers. So for one 22 kilowatt charger, you could put one single phase unit on each of those phases. So 3 7 kilowatt chargers to replace that one 22 kilowatt. What's the difference? Not really that much when you consider what these devices are used for. Most people use these devices to charge overnight. So the difference between a 3-phase and a single-phase charger when charging overnight, you're probably going to arrive at the same charge amount in the morning when you need it. Another sort of consideration to take on board is your second car. You know, Australians tend to have more than one vehicle. You know, you'll have your primary, that may be your EV, and hey, look, it's worked out so well, I'm going to buy my second one. What are you going to do with the second one? Stick it on the other phase, you know, and still you've got the other third phase, could go to your home battery. The other one here, obviously not portable. If you sell your house, you know, then you have to get a registered electrician to then take it off the wall and then reinstall again, additional costs. Parking space, you need a parking space. An off-street parking space to actually charge the vehicle. There are a few councils that are sort of running pilots where you can park on street and run cables, but you know, it's a very, very difficult proposition and something that's probably not going to change very, very quickly. And again, one size does not fit all. So let's look at what Ohme has to offer. So we've got the Home Pro. Home Pro is a tethered charger, just like this one up here. Actually comes with the cable. It stays with the charger. You can't take it with it. It's convenient. The other thing about the Ohme Home Pro, it's a sealed unit. So in some units, for example, this one here, which is the one I'll talk about next, you actually have to open it up to provision it. And what can happen is some installers can damage the electronics inside, opening it up to dust. So there's a few considerations there. So the fact that it's sealed, you know, you're going to get less sort of warranty issues with the unit. Also comes with a 1 meter banded cable, which will just go into an isolator unit. And what we've found is the screen. So a lot of the older generations don't like using apps. And so everything can be managed from the screen. You can even set schedules there. You won't get the full sort of experience that you would from an app, but it's fully functional and it's quite bright. It changes color based on what sort of charging profile you're doing. And yeah, it's a good charger. I've got one installed at home. And then obviously here, the Ohme ePod, which is our socketed one. So this one here, cable type 2 to type 2. You can take it with you when you leave, put the cable in the boot if you're traveling or want to do some public charging. So we actually design and assemble all the hardware, and that's all done in the UK and shipped through here to us here in Australia. We're compact and robust designs. So for what the features have, it's actually quite a small profile unit. We develop all of the firmware and all of the software in-house. So we do not outsource any of this. It's all developed in-house. So we have control over how it's done. And to begin with, Ohme was a software platform company. And what we found was we were designing all of the software, but then we had to adapt it to every hardware that we had. And so as hardware changed, as different companies sort of changed things, it just made that experience for the end user not that great. So we realized that actually we need to make the hardware as well as the software. We also include the CT clamp with the unit. So what does the CT clamp do? It sort of is used for measuring what energy is coming in and what energy is coming out. And so as I discussed, when my swimming pool pump came on, when my spa pool kicked in, it would actually derate the charger. And as that load came off, it could then increase the rate of charge on the charging station. And also used to sort of determine excess solar usage. So here you can see max charge current, 32 amps. Currently reading 1.9 amps usage on the clamp. I've got load balancing on, and my load limit for my house, it knows that I've got a 40 amp supply. So the charger will sort of manage that all in the background using the software. Let's look more into the smart features and sort of look at how you could potentially benefit from them. So one of the key things at Ohme is our technology can integrate with your EV. So here's a screenshot of my app, and it's got here my Tesla Model 3. Oh, and there again over there. So you've got 53% it's reading as my battery state of charge. On my actual Tesla app, it also shows 53% state of charge. So what does this mean? It means that Ohme knows that I've got 53% of battery. Say I want to charge my car to 80% by an X amount of time. It knows what the current battery reading is. It can set a schedule to make sure that I can achieve my battery percentage for the time that I want it. If it can't achieve that, it will let you know as an alert. But it's those types of sort of smart features, that makes it better for me. You can decide not to opt in and pair your Ohme with Tesla, but the option's there. Tariff integration. We all love paying our power bills, but it's also good to know, how much is this costing me? So what you do is you'd find out who your supplier is, and then what sort of tariff do you have? Do you have a time of use tariff? Do you have a multiple rate tariff, a dual rate tariff? Why is this important? What it will do is help you set schedules, and I'll go into the next one. So we're looking at optimizing charging. So based on the tariff that you select and price rules. So for example, here, I've got Amber as my tariff. I've put in a price cap of 12 cents per kilowatt hour. So you can enable a price cap where you can say, hey, I don't want to charge over 25 cents per kilowatt hour. I want to charge to 80%, and I want it ready by Tuesday at 7:30 a.m. So what it will do is it will create a smart charging schedule. It'll give you times at what your battery is going to be at. You'll notice up here that it's got 3.78 kilowatts. It doesn't have to charge at the full amount. So it may be checking what your current load is. It'll be checking what your current rates are. It'll be looking at, is this going to affect my battery state of health? So it will derate and increase that based on sort of the metrics that you sort of put in. So again here, here's your charging schedule. Starts at 12:11 and finishes at 6:28, a little bit earlier than I needed it, where I'd be at 80% battery when I need the car. Excess solar. I'm briefly going to touch on this because my energy will probably go into a little bit more detail. But basically, what you can do is enable a feature called Solar Boost. And what that does is it reads excess sort of energy coming through. We need a minimum, so if you're doing a mix of grid, you need a minimum of 3 amps to sort of initiate the charging session. It'll pull the other 3 amps from the grid, so 6 amps to sort of initiate the charging session. If that falls below 3 amps, there's a period of roughly 3 minutes where it won't initiate it, or you have to wait, and that's purely just to protect the vehicle. So we don't want it switching on and off, on and off. So there's some smarts around it to make sure that it's protecting your interests. And here you can sort of see what your charge sessions are. So it provides you sort of the total cost, energy used, what amount of energy came from the grid, what came from solar, how much you saved based on your tariff that you inputted, $2.25, how much of that was in savings in dollars, and sort of the CO2 gram sort of savings as well. And just on that tariff integration, so what will happen, sometimes your rates may change every year on the annual thing. They'll update automatically in the background. So, that takes you having to go back and sort of entering in that data again. So what if you don't want the smarts and you need energy now? So the power's in your hands, right? So you see here, it's charging at 3.82 kilowatts. I've set it to be ready by Friday at 11:30 a.m., charged to 80%. I'm going to turn on max charge. Max charge overrides everything, every rule that's behind there. So we give the power to you. So we may say, oh, you've got to take these considerations. If you want it, you get it. And so what will happen, charging 7.56 kilowatts, and it's changed it. It's going to be actually ready to 80% at 1:02 a.m. So it'll actually give you a time of when it's going to be available for you to drive away. So what's next? Sort of integrations. So you'll see in the media, there's a lot of energy retailers that are very, very interested in how you charge a vehicle, balancing it against the grid. And so what we've done in the UK, so for example, we've partnered with Octopus, we've also partnered with Ohme Energy, and we have integrations where we tie in that user logging in their account into the Ohme sort of ecosphere. So what that does is it gives Octopus an amount of freedom to assist you in your charging, so they can sort of initiate, right, we don't want you charging during these peak periods, but as a benefit to the customer, you probably get better rates. In saying that, max charge is always there. So if you want to override it, it overrides anything that say Octopus or Ohme would want, and so it still gives that sort of control back into your hands. There may be a consequence as a result of doing that. There may be some penalties from Octopus or say Ohme. But this is what the sort of industry is going for, to sort of provide these options through to customers. And you'll see a lot of energy retailers in the space in probably the next year or so, sort of vying for your business and sort of vying for how can they sort of get involved in this. There'll be a lot of things around sort of VPP, etc. What else for us here? Sort of other integrations with vehicles. So all of these ones we already have integrations with in Europe. And so what we've done is we're just doing a staged rollout. So, if you've got a new Volvo EX30 and you want to integrate your battery state of health, we'll have that integration available through the Volvo app. So it'll be available in the Ohme app. And then obviously V2X. So what will be happening in this space, it's quite a big thing. It's going to be DC bidirectional charging, but we companies like ours that are working on AC sort of V2X solutions. So it's something that we have in our product pipeline that we'll be bringing to Australia. And thank you. Any questions? If not, I'll be available afterwards for a chat as well. Okay.
The smart features, what do you want features to support to, let's say your car has a battery, and you charge that in bed, and we want to all minimise or replace the energy companies. Can you use the car to charge the house out, power house?
So that sort of that bi-directional sort of functionality, currently no, and there's no AC vehicle or charger in the Australian market that does it. There are some projects currently that do. So you may be talking about V2L or vehicle to load. That's directly run from the actual vehicle itself, not sort of that device. That sort of is that proxy.
I meant if you sort of got solar in the day and the feed-in tariffs are so crap.
Yeah.
So just step on that, just charge the car, EV, and then use the car later to power the house.
Yeah. That's something that will be part of the sort of V2H that would be called. And so we call it V2X. It's a vehicle to everything sort of a solution. Yeah.
One thing that was mentioned 2 weeks ago, we did a workshop with Franklin, is that battery there has a changeover switch in the A gate for it. And the changeover switch, you can plug a generator in, but he had a point of any changeover switch that you have connected to a switchboard, you can actually just plug any power supply into. So a lot of cars like BYD, I think, that have the V to L, you can actually just run an extension lead from your car and plug it into your house, but it's only when the house goes off grid.
Okay.
So you can't do it normally, but if there was a grid outage and you had a car that had a V2L power point, you could plug it in if you had a changeover switch, like for a generator or something. But as far as just basically unloading your battery every night, not really there.
I'm saying probably 2026 is when you're really going to see it in the Australian market, not anytime soon.
Feed-in tariffs are so generally so crap. You've got a little bit of battery in your driveway, you might as well use it. And okay, you've got to make sure there's enough power there when you drive it.
Yeah.
Yeah, I think the best thing to do is leave your car plugged in when it's sunny where possible, and then just use the excess energy on the road in your car. I've got a battery, but that's generally what I do, is the best way to make the most out of it. But all right, we'll swap over to my energy now. Actually, I just had a question before we go any further. How many people here actually own electric cars currently? Does everyone own electric cars? Okay, and how many have solar at their house? Nearly everyone. Okay, cool. All right, well, you're in the right place. So